All right. So hello, everyone. My name is Ralph Potter. I work for Samsung. I'm the Vulkan Working Group Chair. And today we've got 90 minutes of talks and Q&A time on Vulkan. So if I get us started. First up, feel free to take photos. We're trying to tell you about stuff that we want to share with you. Record whatever of it you like, there's no problems. The slides will go up on the Kronos site after the fact, so there will be an opportunity to get them there as well. Okay, so the session for today, I'm going to talk for 30 minutes. We'll see if I get it into 30 minutes about what we've been doing over the last year or so in Vulkan and where we're headed. After which Karen is going to take 25 minutes to talk to you about the SDK. So Vulkan is not just a spec, like the tools and the ecosystem is important. Karen is going to talk to you about that. Andrew will talk to you about Vulkan SC, so the safety critical variant of Vulkan that exists as kind of a sister spec to Vulkan itself. And then Michael and Henrik from Autodesk will talk about support for Vulkan that's been added to Autodesk's VRED and Alias products. And then at the end, we'll have some time for Q&A and some open discussion. So hopefully this is not news to anyone in the room, but Vulkan is an explicit API for graphics and compute on GPUs. We are cross-platform. We exist on embedded devices. We exist on mobile phones, desktops, some consoles. And the focus has always been on high performance and user control. Perhaps newer to us, we're now in a position where we're also able to influence the development of future hardware. So we're now at the point where we can decide that we want something in the spec, and we can talk to all of our vendors and say, this little hardware warp, could you maybe fix it in a future device? That requires quite a lot of looking ahead. Hardware roadmaps are long. You probably need about 5 years run up to get something changed in hardware. We now have enough planning that we can begin to do that. Which is maybe different from how things might have been 4 or 5 years ago. So Vulkan is everywhere. It's supported on all of the major GPU hardware platforms. It's also supported in all of the major engines. There's a good variety of desktop content, plenty of mobile content. We're also seeing kind of really good adoption in professional graphics and the like these days. There's going to be Autodesk talks later, for example. So one thing that's new since last year, in December of 2024, we announced Vulkan 1.4 at SIGGRAPH Asia. So that brings a bunch of extensions into core, 16 extensions into core. In particular, dynamic rendering local read means that we can now support kind of tile-based GPUs, keep all of that functionality without using the old render pass API. So we have a much more ergonomic way to access tile memory now. We also made it mandatory that there is a way to stream content from the CPU onto the GPU without interrupting rendering. Now that might be through a dedicated transfer queue, or it might be through the host image copy extension, which we promoted to core. And then a bunch of other bits and pieces. We offer more fine-grained control of floating point. We made a bunch of previously optional features mandatory to give you a more consistent experience. We pulled in the maintenance extensions, etc. One other thing that was new for Vulkan 1.4. So Vulkan 1.0, the design work for that was done in 2015. We launched it in 2016. 2015 was a decade ago. the spec that we used back then was basically a GLES 3.1 class GPU, and the GLES 3.1 spec was published in 2014. It was important that Core could run on what were the devices of the day, but we never raised the minimum hardware specs again since then, which essentially led to a bunch of optional functionality and some artificially low limits. So in Vulkan 1.4, we finally decided to bite the bullet and raise hardware limits to what we regard as reflective of the hardware that people are selling and that is active in the marketplace today. So we made 28 previously optional features mandatory, including some really fundamental stuff like scalar block layout and 8 and 16-bit integer support. We raised limits on 31 properties. And the goal here is to give you something that's a bit more reliable and predictable across all platforms. But it was a big step for us to finally move those limits. So I want to talk about kind of how we've been structuring our work and the relationship between roadmaps and profiles here. So we have been producing on a 2-year cadence what we call a roadmap profile. The purpose of that is for all of the hardware vendors to come together and agree a common set of functionality that we will all ship. Some of us might only ship it on a single device in the named year, but the agreement is we can all implement this and it will make its way into our offerings over time. So you can think of roadmaps as a sign of where we're going. I'm not suggesting that you should take last year's roadmap and make that the baseline for your application. Maybe if you're on desktop, you might get away with it. If you're on mobile, probably not. But it's directional, it tells you what's coming, and it serves to get the working group to all align on a common agreed set of functionality with the goal of reducing fragmentation. We also produce core specs on a 2-year cycle. It's supposed to be a tick-tock of roadmaps 1 year and core the next. That didn't quite work out last year. We had to pull the 1.4 release forwards a little bit to align with Android's release schedule, but that's the basic premise of how this is supposed to work. And for 1.4, we were essentially able to look at what we'd put into the roadmap 22 and 24 profiles and take most of it and merge it into core. Not everything, because roadmaps are kind of forward-looking and cores are supposed to be a wider baseline, but a lot of the stuff got pulled in, which is essentially the context of this slide. So 1.4 was the first core version where the roadmaps had been out for long enough that we were able to use them as the basis of our core. So like by the time we came to produce 1.4, most of our difficult questions had already been agreed. We'd already had the arguments about, was someone going to go and do the driver work to add a missing feature, or was something impossible for hardware reasons? And 1.4 was largely a matter of pulling things together and just promoting the bits that we knew we could all do, which was a much easier development process than usual. That was what allowed us to pull in the schedule to hit the Android roadmap. And that essentially means that Android 1.4 landed on, or Vulkan 1.4 lands on Android a year earlier than it otherwise would have done. So, adoption. Adoption has been good. All of the major vendors have 1.4 drivers. At least on desktop, everything is there. The big mobile vendors are there. So that has been good. The Mesa story, those guys really speed ran release. By the time I got up on stage to announce 1.4, like it was all done. They were ready to go. That was awesome. Molten VK, functionally it's there. There are some reasons why Molten VK can't quite pass conformance to do with limitations of the Metal API that it's layered on top of, but I believe Bill told me that it was a 98% pass rate, and the things where they fail are minor corner cases that you may never hit. So we can't officially say it's conformant, but it's plenty good enough for you to ship your apps on. It's basically there. I also wanted to talk about Vulkan adoption on Android. So Vulkan is the recommended graphics API for Android. It continues to gain traction there. For people shipping new SoCs, it's mandatory to support Vulkan now, which did not used to be the case. And Android has a plan to replace the native GLES drivers in future Android versions with Angle, which is essentially a OpenGL emulation layer that runs on top of Vulkan. That's a multi-year plan. We're going to ease into it. But the intent is that we get to a place where Vulkan is the graphics driver on Android, and the rest of the graphics content is layered on top of Vulkan. We also think that will get us better driver quality once everything is flowing through the Vulkan drivers. The Android ecosystem is increasingly moving towards Vulkan. We've had some great titles recently. Delta Force Mobile, Game of Thrones are great. Those are kind of high fidelity titles, but we've also seen kind of good benefits from less kind of heavy titles like the Pokemon TCG, which also shipped using it widely kind of across their devices. In terms of momentum, so these are brand new numbers. 48% of sessions for new Unity titles are now running on Vulkan. So Unity recently switched so that the default on Android is to enable Vulkan and you have to opt out rather than the other way around. We're seeing good returns from that. And I expect that to continue to kind of accelerate rapidly. Last time I asked what the numbers were, it was 40%. It's now 48%. We're going in the right direction. Finally, web GPU. So mapping Vulkan to kind of Java and Kotlin is not that straightforward. Android is going to roll out web GPU and bindings for web GPU from Java and Kotlin. But web GPU will just be a layer that sits on top of Vulkan. So just as how Angle works with GLES, web GPU will be translating your API calls down to Vulkan calls. Ultimately, everything goes through a Vulkan driver. Right, so now I want to talk about something that the working group has really been working on recently. This is kind of our driving, overriding goal at the moment. Vulkan, we did the design work a decade ago. We released it 9 years ago. We've learned some things since then. The hardware has evolved a bit since then. Some of the constraints that we had in 2015 don't apply anymore. So Vulkan was designed to be an explicit API with no compromises. In places, it's complex. I said we're now able to plan for hardware roadmaps. One of the things we're doing is asking hardware to evolve to fix some of those rough edges. And we're trying to design features that are much more ergonomic and pleasant to use. So some recent examples of that kind of dynamic rendering is way more convenient to use than the old render pass API. Now we've got local read. Unless you have to support older devices, just move on to dynamic rendering and local read once you're writing something from scratch and you're ready to go. Unified image layouts, which I'll talk about later on, again, kind of simplifying synchronization, making the API more pleasant to work with, and shader objects kind of tackling the explosion of pipelines and state management. We are also recognizing that navigating Vulkan is becoming challenging. The API surface has become large. We've revised the API by adding things like dynamic rendering, and now there are multiple ways to do the same thing. So we need to find a way to help people navigate the API better, and that's something we're kind of actively working on. And again, the rest of my slides will be talking to this topic. So, what are we doing about it? There's not one simple solution. This is a big set of problems. There are lots of point solutions that we are applying to try and get to the end goal. So, lots of work goes into tooling and the SDK. Karen will talk about that shortly. We've got 8 new API changes like dynamic rendering and unified image layouts. Beyond that, there are more things to come in terms of changes to the API. We've previously kind of alluded to but not shared the fact that but not really shared details of the fact there will be changes to the descriptor APIs, better stuff to do with state management. And yeah, a focus on making the API a joy to use, try and remove some pain points. And then longer term, hardware requirements, hardware changes as needed, and continuing to raise the baseline as we can. In terms of accessibility, I'm going to talk a bit about the docs site that we revised last year. Also at the end of my presentation, there'll be a pointer to a developer lab at SIGGRAPH, which I encourage you to stop by and take part in. There's more work coming on samples and tutorials, some developer outreach events. We've been running Vulkanized for, well, there was a one-day version of it for many years, but the last 3 years, I believe, we've been running a 3-day developer event. We will run that again next year as well. There'll be another slide on that. But we are also now going to run a 2-day event off the back of it, co-located, to deal with shading languages specifically. Again, I'll talk to it later. But developer outreach, giving you the opportunity to come and talk to us, tell you where your pain points are, and for us to give you some guidance in return. We continue to work on documentation, and I'm going to talk also about a formal model for deprecation, which we've just started on. Longer term, we also have an effort to reach out to educators to try and help guide students and newcomers of the API to what we recommend, because right now it's very easy to go out on the internet and find all the tutorials that were written in 2015, and that's maybe not the best way to use the API today. So, documentation. So, at the end of 2024, we launched the docs.vulkan site. Prior to this, we had a bunch of individual pieces of documentation, the main spec, the Vulkan guide that Spencer Fricke at LunarG wrote, our API proposal docs, which are like our design documents, our samples, a Vulkan tutorial, the various shading language documents. And these were all in different places, scattered kind of across Khronos' GitHub and various related sites. And we have pulled them into a single kind of integrated place. Everything is all here. It's all searchable. There is more to come in the coming year in terms of additional content that we're going to pull into the site. But it's a much nicer place to go and find the documentation. Also, it's not a single HTML file, and it won't crash your browser when you try and open the spec, which is nice. The number of times I've randomly clicked the wrong link and crashed my browser. So, Vulkan samples. The team have been working to modernize our samples. I've said we've changed the API in places. We need to bring the samples up to date to reflect that, and also to reflect kind of changes to how people are programming. So more modern C++, Vulkan 1.4 alignment, dynamic rendering, a modernized set of synchronization samples, also modernizing the samples to build with CMake and to tightly integrate with the Vulkan SDK. That's ongoing work, but we've done a lot so far, more to come. The Vulkan tutorial, so I'm sure lots of you are familiar with vulkantutorial.com, which Alexander wrote back in the 1.0 days. He's graciously allowed us to take a fork of that, pull it into the docs site, and we have been working to modernize that. There's been a lot of work from both Steve at HoloChip and also Sasha Willems to contribute to updating that. We've got new sections on shader authoring in Slang, handling modern asset formats, some ecosystem utilities, explaining Vulkan profiles, better Android support. There's more on top of that, and again, more to come. Now, the Educators Forum, we want to help educators kind of integrate the latest API improvements into their curriculums. We want students to come out of it being informed about how we believe you should use Vulkan today. So the Kronos team have created a private Discord channel to provide a forum for educators to talk to us and talk to each other, share your experiences about teaching Vulkan. If you're involved in teaching Vulkan and you'd like to participate, whether it's teaching online or in person, please reach out to the marketing email. Don't be scared that it's marketing. You'll end up with Marty from DevRel. We'll hook you into the Discord and we can get the conversation going. Now, unified image layouts. So it's no secret that synchronization in Vulkan is a pain point. Tracking image layouts and managing transitions adds complexity to applications. And back in 2015, it was important for some hardware. Nowadays, a lot of drivers, almost all drivers, actually resolve that to no ops anyway. All we're using image layouts for, really, is to control image compression and decompression. And over time, hardware has become more capable. We've been able to leave compression turned on in more cases. And so you do a layout transition and we just leave the compression turned on anyway. So you're doing a bunch of tracking work and we're ignoring it. So unified image layouts essentially promises that using VK image layout general will be performant in almost all cases. And by almost all, what I really mean is there are a few cases where we can't delete the general layout because it is used for something, or where we can't delete the non-general layout because it is used for something specific. So a couple of cases of that. Undefined typically means the driver is allowed to go and throw away or trash whatever's there. We need something that says that. So layout undefined, you can't map that to general. We still need layout transitions when you're doing anything external to Vulkan. So that might be kind of external sharing. That might also be QPresent, because QPresent is really taking an image from Vulkan and handing it off to a presentation engine that might be a completely different piece of hardware that doesn't understand compression. But the number of cases where you actually need something other than general is way smaller now. So don't take my almost to mean there's some weird performance pitfall. What it really means is there's a handful of cases where layouts mean a special thing, and those had to stay and we couldn't delete them. But otherwise, if this is exposed on your device and it makes your life easier, just use general. It'll be fine. Shabazz from Google did a ton of work on this extension. He has a great blog post talking about it. Link on the slides. And again, slides will be published afterwards if you want to find the link. So let's talk about deprecation. So first up, what do I mean by deprecation? We have no plans to remove any functionality from Vulkan. Nothing is getting deleted from people's drivers. Applications need to support a broad range of hardware for a long time. Maintaining duplicate code paths because somebody deleted functionality is not the way to make ourselves popular. We have a strong desire to keep backwards compatibility. It has to stay in. But what we do want to do is we want to guide developers to our recommended solutions for things. So it turns out we actually have deprecated things before. There are random ad hoc places in the spec where it will just say in a line of text, this thing is deprecated by this other thing, but it's not really formalized. You have to know it's there. I discovered a few the other day that I didn't know we signed off on. So we're formalizing that and beginning to reflect it in a more consistent manner in the spec. And I'm going to talk about how that works. Now, having said that, if we deprecate something, there may still be market-specific reasons why you need the legacy functionality. If your business model is to get maximum reach on Android, and there are devices that aren't getting driver updates, you probably can't just delete all the render pass code, because you'll only get the last couple of years of devices. Which again is why we can't just delete functionality from the spec. This is really about guiding you to recommended best practices. It's not about removal of old functionality. So what have we done? We build a bunch of stuff from the spec from an XML document, and we have started tagging functionality that is deprecated or superseded by something else in the XML, and we can now reflect that through into the specification. So now if you click on the specification for create render pass, for example, you'll find a little note that warns you that it's deprecated, and you'll find a hyperlink that points you to something that explains why and tells you what version of Vulkan it was deprecated in. So we have an appendix that basically tells you why it was deprecated, what it was deprecated by, in what circumstances you might want to act on that piece of advice. All of that is effectively hyperlinked so that things like validation layers can also point you to the same things. Which brings me on to tooling. So validation layers, again, Spencer at LunarG has written some validation layer code that will warn, first of all, you do have to opt into this, but if you enable it, it will warn you if you're using something that we flagged as deprecated and that your device supports the newer thing. That hasn't merged into the SDK yet, just because of the SDK release cycle, but I believe it will be in the next SDK. If you want it before then, I believe Spencer has merged it into the main branch if you build validation layers yourself. I'll also point to the Vulkan object scripts. Now, we haven't publicized these very widely, but a bunch of people parse our XML files to do code generation and the like. And every so often we go and monkey with the schema for our XML files to add something new, and we break those tools. Spencer produced a bunch of Python scripts for actually parsing the XML and instead giving you kind of some instructable objects to express the API. You should really go use it. It's way more friendly than parsing the XML yourself. It's way more stable. It now has support for telling you when things are deprecated. There's more to come here. We haven't finished. We've discussed things like whether we could generate compiler warnings when you use deprecated functionality, whether we might have options to build headers that don't contain superseded functionality. That's all TBD. We haven't come to a final solution there, but there's a lot we can do with the tagging in the XML. One other thing I'll say here about there being more to come, we haven't picked up every single item in the spec that is deprecated or arguably superseded where we did a version 2 of a entry point just to add extensibility. Not all of that is in the appendix yet. It will come over time. It's a matter of just triaging the spec and merging in the changes. So this is an evolving process, but we're working on it. Right, so now I'd like to talk a little bit about Vulkan Video. So the video extensions, we released 2 extensions recently, VP9 decode, which a lot of people were asking us for, and also intra refresh. Hopefully VP9 decode is obvious. Intra refresh I'll talk a little bit about in a second. In terms of ecosystem adoption, FFmpeg 8 should release in a few weeks. That has just added AV1 encode and VP9 decode support. We've also added support for the video extensions to the Vulkan info tool and to the Vulkan profile layer. And while I'm on this, just a little note of caution. There are some buggy drivers out there that don't quite report the correct capabilities. We are aware, we're working on it. Driver updates will come in time. And then finally, on the topic of FFmpeg, There is also some stuff in FFmpeg that doesn't use the video extensions, but uses Vulkan Compute for other codecs. So FFV1 encoding and decoding, ProRes RAW decoding, and there's more to come for ProRes encode, decode, and some other formats as well. So those of you who are engaged in video, go take a look. In terms of video itself, we now have quite a suite of encode and decode extensions. Basically, all of the major codecs are covered now. As I alluded to, the newest things, VP9 and encoder intra-refresh. For intra-refresh, just to explain what's going on here, for those of you who aren't familiar, video streams are typically made up of iframes, which you can think of as a whole image, and then predicted frames that are kind of like a diff from the iframe. So it builds on the iframe. What that means is if you get corruption and then you do a bunch of predictions off the back of it, those will also be corrupted. It also means that iframes are kind of spikes in terms of bit rate because it's a full image, whereas the predicted frames are much smaller. So intra-refresh is a relatively simple idea. It's essentially taking a portion of the image and updating that as if it was an iframe, so giving you kind of the image data, and then you can predict from there. This is good both for more stable bit rates, but also for things like live streaming. It reduces error propagation. So for those of you that matters to, this is out there. It's great. Please take a look. Now, just very quickly, a couple of kind of advertisements for things that you might want to go and see. We have a lab session tomorrow, 11:45, in the exhibit hall on Vulkan ray tracing. So Jose Emilio and Steve will basically take you through. We have a framework. They'll take you through kind of enhancing a renderer with ray tracing, some work with pulling in some slang shader functions. Yeah, please go take a look. And then 2 events. I alluded to these earlier. So Vulkanized, this is a 3-day event. The next one will be in San Diego on February 9th through 11th. The call for submissions for talks is open now. There is a cost to the event, but we do run it at cost. So we're not making a profit. It's just to cover the cost of running it. It's 3 days. I think it's an amazing event. I'm really proud of it. I hope to see all of you there. Every single one of them has been great. It's 3 days of nothing but Vulkan content. You'll get a mix of developers, working group members. So yeah, really proud of that one, but I'd love to see as many of you there as possible. And then something new running immediately after it, also in San Diego. We're going to run a shading languages symposium. We have participants signed up to give talks from all of the major shading languages. So there'll be GLSL covered, there'll be HLSL covered, slang. To my knowledge, there's never been anything quite like this previously. We're really excited to see how it goes. So for those of you who are interested, again, the call for submissions is up. Yeah, I'd love to see what anyone brings. I'd love to see you there. So finally, just a few resources. I'm not going to leave this one up for long because I'm hitting time, but it will be in the slide deck if you want to pull it from the Kronos site afterwards. And finally, from all of us in the working group, thank you for your time. Thank you for your interest in Vulkan. And so we'll have time for questions at the very end of the session, but now I will pass us over to Karen to talk about the SDK. Green button for forwards, red for back.
Okay, I think I'm ready to go here. All right, so let me just talk a little bit about who am I. I actually am a Hewlett-Packard veteran. I was there for 35 years. I took over LunarG as a CEO and engineering director back in 2015. So 10 years is my anniversary coming up in October. I have a strong desire to have a lasting impact on the success of the Vulkan API, and as such have been driving the Vulkan ecosystem tools and the developer tools in the Vulkan SDK. And just to clarify who LunarG is, because I do get a lot of comments or questions about this, we're an independent private company with Kronos membership. We're a bunch of GPU software specialists, and we developed the Vulkan ecosystem components since 2015 with lots of generous sponsorship from clients. Largest ones are Valve and Google. Okay, so 1 year ago, these were the components that were in the Vulkan SDK. And all of these components were supported on Windows, Linux. We had Ubuntu packages and the Linux tarball format, Mac OS, and also Windows on ARM. We started shipping just last summer, so it's been 1 year. So what I'm going to do is go through pretty quickly and just show you the enhancements or additions or changes to the SDK since SIGGRAPH a year ago, in case you may have missed some of these and there might be something that is of interest or use to you and it's time to upgrade to the newer SDK. So starting out in October, we added slang. Shannon mentioned this previously in her talk. We added it to all 3 platforms, and it continues to ship, and it's quite popular, as I'm seeing in the ecosystem surveys as well. So as you know, the slang, it's a shading language and compiler, and it's overseen by the Kronos Group Slang Initiative. And it's based on more than 15 years of collaboration between researchers, and it's widely adopted in production projects across the industry today. So also last October, we completed the synchronization validation for the timeline semaphore API. And this was the first SDK that included synchronization validation for this API. It was in high demand, actually, by Vulkan application developers. Mentioned frequently in our surveys that it was needed. And then in January, after the release of 1.4, we updated all the components in the Vulkan SDK to support 1.4. Also, with that SDK, we made a little bit of a change about how we're going to handle the Vulkan loader or the Vulkan runtime. Before, it was just delivered in Windows in the driver packages by the various IHVs. We did have a standalone package on our download website, but now we automatically upgrade to the newer version during a Windows SDK install. And the primary reason for doing this is that we had some features coming to Vulkan Configurator that would require a newer loader. So we wanted to start pushing people out there in the ecosystem to the newer loader. And it's better just to get on the newer loader over time as well. Also in January, we had done some work on GL Slang scrubbing the ABI, making it so that we could deliver a dynamically loadable library for this. Again, another request from many people in the ecosystem. But we had to get pretty explicit and clear about what the ABI is going to be in order to do that. Also in January, we were busy for this January SDK. We removed all the 32-bit libraries, with one exception. We did keep the 32-bit Vulkan runtime, and that was just to enable running of 32-bit applications. But we no longer saw any need for anybody to be developing for a 32-bit application on a Windows platform. Since they've been removed, I haven't heard peep in terms of feedback, which is validation that we really didn't need to be shipping those. I should also note, Linux from day one has only supported 64-bit. In January, we also added support for graphics reconstruct on the Mac OS platform. When I add something to the SDK, I like to make sure that it's in some continuous integration and being tested on a regular basis. And there were a few code changes that were required for it to work on Mac, but it's now supported on the Mac platform. And then in February, we added portable ray tracing and buffer device address support to graphics reconstruct. So what does this really mean? So during capture time, tracking is done, and then a translation is done at replay time, and this enables some device independence. And this is done for buffer device addresses, shaded group handles, and acceleration structures. And if you want to know more details about it, I have a link to a white paper here. Don't worry, the presentation will be online afterwards. You can follow the link. So now, buffer device address portability and graphics reconstruct, it was just building upon the techniques used for the portable ray tracing implementation and graphics reconstruct, applying similar translation strategies. And again, there's a white paper that just released about a month ago that goes into more details about how that was implemented as well. In February was when we released version 3 of the Vulkan configurator. And this is why we needed the newer Vulkan runtime or Vulkan loader out there, because there is a lot of close coupling going on between the Vulkan loader and Vulkan configurator to enable some of these features. Now, I'm not going to tell you everything that was in VK config 3. These are just a few of the highlights. We did a lot of work on the GUI to make it easier to use. It's more of a tab-based design now. We added improved diagnostics that helps troubleshoot your system installation. You can identify the physical devices that are present, your loader settings, your Vulkan configurator settings. We made improvements to logging support for the loader. You can log outside of the application launcher. You can control what level of logging you want from the loader. And we improved layer ordering and loading and selection. So you can have multiple versions of the same layer selectable now from Vulkan configurator. This is useful, for example, I want to switch between previous version and current version of validation layers. I think I'm getting some different errors. What's going on? And hence, the settings per layer are controlled by layer, and then you can control the order of the layers that will be activated by the application. So quite a few useful features. And then also in February, so Ralph talked about the Vulkan docs site, and he talked about the slow HTML single file for this specification. We updated the version of the spec that's with the Vulkan SDK to use this new Antora-based build. So I know there's a lot of text on here, but the key, and you don't need to read it all, but the key is the way it used to be. So when the validation layers get built to be delivered with the Vulkan SDK, they are built in a manner so that all of the URLs on every error message is pointing to the specification version for the SDK, not just top of tree, okay? And that was pointing to the single HTML file, and it was really, really slow to load in your browser. So by switching to the Antora build of the Vulkan spec is what I call it, those URLs now point into an Antora build that we've done of the SDK version of the spec and included in the SDK, and it loads very quickly. So it's a much better user experience. Okay, in March, more improvements were made to error messages for the validation layer. This has always been a big sore spot on our ecosystem surveys in terms of open-ended feedback. Truth of the matter is, validation errors are just hard anyhow, and there's a lot of information, and people don't know always how to parse them. So Spencer turned on warnings by default, but he got rid of the clunky list of objects at the top of the message. It's more dense and easier to read with a new format. So the first line is your VUID, your object list, and some other metadata followed by the real message. And the third line is the link to the actual VUID text within the specification. And there's also a new option now to output in JSON format. Okay, come May, because of Vulkan Configurator 3, all the diagnostic information that existed in VK-VIA is now available through Vulkan Configurator 3. VK-VIA was a tool written 9 years ago, right after the release of Vulkan, and LunarG was getting inundated with questions about why isn't my Vulkan installation working? And actually, Mark Young, who was here, wrote this tool so that when we kept getting these questions, we would tell them, run this, and it would give us a bunch of information about their installation so that we could help them debug what they were doing wrong. But now everything that was in VK-VIA is now in Vulkan Configurator 3, and I'm always happy to get rid of something that we don't have to maintain inside of LunarG anymore. So we nuked that, and we even removed it from the Vulkan Tools repository. In May, we also added the ability to do cross-compiling between Windows x64 and Windows ARM. And basically, you can find the other platforms' libraries in a directory after you install your SDK. And then the SDK that just released in July, it feels like it was just yesterday, but it's already mid-August. In GeoSlang, there was a SPIR-V remapper optimization utility, and we wrote it in SPIR-V tools style language and moved it into the SPIR-V tools repository as another optimization pass. And the reason for doing this is that optimization passes now are all in one place. There isn't this one lone guy hanging out in GeoSlang. But it also removes a dependency that applications, if they were using the remapper, they don't have to link to GeoSlang anymore, and they were already linking to SPIR-V tools. So it removes another dependency from applications. The other thing that we've done, which I was expecting more complaints, but it's been really quiet since I did this in July, but we did give 3 months of heads up via social media and release notes. We have discontinued the Ubuntu packages. And the reason why we did this is there really was a lower usage rate of them. And everything you need, you can get from the Linux tarball. And I'm always looking for ways to streamline resources so that LunarG can continue to work on useful tools for the developers. And if we just keep adding and adding to the plate but never take things away, we eventually get saturated and can't do anything more. So the packages that do exist will be out there for about 2 years, but then they will disappear. And this is in line with my general policy of any SDK older than 2 years is removed from the download site, no longer supported or made available. So just a reminder, where do you get the Vulkan SDK? You get it from vulkan.lunarg.com. Out there you'll see platforms for Windows x64, Windows ARM, the tarball, and for Mac. And I always show these graphs, but the download rates continue to be very healthy and show good trends. No trend line yet on Windows on ARM. It's pretty soon. It's pretty early, but it seems to be going the correct direction. Okay, so this is not in the SDK yet, but this is some ecosystem work that LunarG is doing, and I wanted to make a public announcement of its availability is coming. This is under development. It's the Cosmic Crisp driver. It's a Vulkan on Metal Mesa 3D graphics driver that we're developing. It will only support Apple Silicon. We're not planning to support any of the older hardware, the AMD and Intel GPUs. And it will be Vulkan conformant, so it will eliminate the need for the Vulkan portability solution. So what inspired us to do this? Last fall, Alyssa Rosenzweig, I think, announced her Honeycrisp Linux driver, which basically is a implementation poking directly at the Apple hardware registers on Asahi Linux. And she demonstrated Vulkan 1.3 conformance. And I'm like, well, shoot, why can't we do that if we're doing a Vulkan to metal driver? And so LunarG started investigating more. Now, why the name Cosmic Crisp? It's a cute twist. Cosmic Crisp Apple was, a bunch of study and research, and was a morph between, had the Honeycrisp apple as part of its breeding. And so I thought, well, we're going to be leveraging a lot of Honeycrisp concepts. So it seemed like Cosmic Crisp was a good name for this driver. So that's why we came up with it. So why are we doing this? And lots of people ask, why are you doing this? There's already a Vulkan on metal implementation today with Molten VK. Well, we want to achieve Vulkan conformance on Apple platforms. And after research into the Honeycrisp techniques, we know that we can do it. And we wanted to be able to get rid of the need for the Vulkan portability so that because there will be a Vulkan conformant implementation on Apple platforms. But also as we researched this, what we realized is that this will enable faster driver development and let us keep up with Vulkan. So it's going to be 2-3 steps back. We have to develop the driver. But once it's developed, it will move much more quickly than what has been able to be achieved with Molten VK. And this is due to the fact that Mesa has their near optimizing compiler stack. And so there's no longer the need to do SPIR-V cross to metal shading language, which is used by Molten VK. That's not really a compiler stack. It's a lot cleaner when we can actually write a compiler. So part of writing this driver was to develop the near to MSL compiler, which we have done so now. And it will remove a dependency on an external project. Now, if you have a defect in the Cosmic Crisp driver, everything is in tree to fix it in that single repository. But Mesa has a very good Vulkan driver framework that we can leverage. As other drivers adopt new Vulkan APIs, we can leverage a lot of that code for the Cosmic Crisp driver. And writing the Cosmic Crisp driver, we actually leveraged a lot of the NVM driver in doing so. So in practice, we're seeing that it's very real. Honeycrisp had to generate some emulation utilities where there was Vulkan functionality that couldn't be done in metal, and we can use those directly and are already using some of them. There's CI regression test suites over in Mesa that we can leverage to actually have some regression testing to keep the quality up of the driver. And there's a broad community of Mesa developers out there. So once this is out in the public Mesa repository, I anticipate that there will be other developers that can help contribute features and fix defects as needed. So it's all in tree and it's MIT licensed. So this has been sponsored by Google. I wanted to thank them for that. They're quite excited about it. They are already testing with the Cosmic Crisp driver. Obviously, their motivation is that they want a conformant, performant Android emulator that runs on Mac platforms. There are a lot of MacBook developers out there that's our primary development environment. So what will this mean for the Mac OS SDK in the future? We will include both Molten VK and Cosmic Crisp. Molten VK for sure will be required for the older hardware, the AMD and Intel GPUs. But also, one thing that is going to be different about Cosmic Crisp is that it's not something you link with your application. It's a driver, and you discover it with the Vulkan loader like you do other drivers. And so applications today that have been shipping with Molten VK may have statically linked to Molten VK. They're going to have to change their paradigm to be Vulkan conformant. But I think it's better for the Apple ecosystem, for Vulkan on metal, for everybody to get there eventually. So it's not like there's no need for Molten VK immediately. There will be many people who will want to stay on Molten VK for quite some time. And we do believe that the Cosmic Crisp driver will be able to evolve with the Vulkan API more quickly, which was a large motivation for us. So where are we at today? We're really close to 1.3 conformance. We have a lot of content running, and we have outside a demo table where we are demonstrating the Cosmic Chris driver, and Aitor, who is one of the primary developers on this driver, is here. He's probably being shy, but he'll be there. Anybody who is interested to know more technical details about how the implementation of this is going, he'll be able to tell you. He was a little bit nervous, but I told him, you know more about it than anybody in this room. You have no need to be nervous. We are expecting that sometime in the fall we will have 1.3 conformance, and we'll be doing, at that point, the MRs to the MESA project to publicly merge it. We have intentionally done it on a private GitHub for now. Too many cooks in the kitchen is just too hard to organize. We need to get the driver structure there, and getting to 1.3 conformance will have a lot of content that's working. It means still that there potentially will be workloads that aren't working and there'll be some bugs, but that's when you make it public and you start asking for people to try it, test it out, submit issues, or make contributions. So all this work that you're hearing about, I need to take a moment to recognize who's funding this work. And Valve was the initial sponsor and is the benefactor of the Vulkan ecosystem as I see it today. They're our most generous sponsor. They continue to do so. And you need to understand that they don't fund stuff only that's of interest to Valve. They fund for things that is of interest to the general ecosystem. And many people forget that, but should be very grateful for what Valve has been doing for 10 plus years. And then Google is a second pretty large sponsor of LunarG, and they do, of course, a lot of internal development, you know, their Angle, a lot of the shader toolchain development, but also are providing sponsorship to LunarG for many of the ecosystem tools. And then Samsung, Qualcomm, ARM, AMD, all in various increments or amounts are providing sponsorship to LunarG for various ecosystem tools. So I think that they need to be recognized for what they're doing. And I am done, and I saved you some time, Ralph. I knew I would make up time for you. So next.
Thank you, Karen. Right, hello everybody. My name is Andrew Garrard. I work for Imagination Technologies, and I'm the attendee of the Vulkan Safety Critical Working Group who admitted to coming to SIGGRAPH and got voluntold to give these slides. I should say, although my company does safety critical stuff and I'm in the meetings, I don't personally do very much safety critical. So by all means ask me questions afterwards, but please make them easy questions. So, Vulkan Safety Critical, what is it? It's intended for when everything falls over, it's more than just inconvenient. Now, I'm not saying that when your code crashes in a game engine and then you spend a week staring at your code looking for a one-character failure, that's not inconvenient. But in the cases where somebody dies, then you don't just get shouted at by a manager, there are lawsuits, your company fails, you feel really guilty. What you really want is a piece of paper telling you that it wasn't your fault. And so Vulkan Safety Critical is for cases where you can get safety certification and people's lives are on the line. And so there are some changes relative to normal Vulkan that are necessary in order to try to make it guaranteed that things aren't going to fall over. And Vulkan Safety Critical is a separate working group, but it's tracking what the Vulkan working group is doing. So the current version of Vulkan Safety Critical was based on Vulkan 1.2, which is what was current at the time that we were working on it, with some modifications in there, but we're still following the Vulkan model of trying to be really efficient, fast, and using modern techniques. So what did change? So first thing is that the compilation is done offline, so you can't really afford to have a stutter in the middle of doing something that's life-threatening, potentially. You certainly don't want your compiler to have updated and that to cause everything to break. I should say that it's not the code that gets safety certified. Normally, it's the entire platform. So you are safe to compile for one piece of hardware and make sure that binary is what is being certified and shipped. So that means that rather than having dynamically changing pipelines in your code, the expectation is that you've compiled everything up front. Similarly, if you're trying to allocate memory, that running out of memory is also a really bad thing to happen in a safety-critical environment. So the things in Vulkan that use up memory, that have limited resources, you need to specify at the time that you create your Vulkan device, and then you can guarantee, in theory, that things are not going to fall over, and hopefully you can prove that. There's some extra stuff in there. Part of it is a fault reporting system that will hopefully tell you a bit more about things going wrong. The other is object refresh. That's optional, but the idea of that is that you certified everything, your memory is all error checking and correcting, but a cosmic ray hit your GPU, and you don't have time to completely reboot the system before you crash. So there is a way of picking up where you left off, which is what the object refresh is for. So there is also an OpenGL safety critical that's been around for somewhat longer, so I should say, why go with a Vulkan version of it? And GLSC has not seen a great deal of attention recently, so it hasn't had a spec update for, well, since last decade. Vulkan itself is more efficient, as hopefully everybody here knows. It minimizes copies. You know exactly what's going to be happening rather than relying on driver optimizations to do things. It's multi-threaded so that depending on your workload, you can make more use of multiple cores to generate stuff. We've heard about shading languages earlier, and as AI, this new thing that I hear of, is taking off, hopefully we're going to be a better platform for that. So just to be clear, when should you use Vulkan SC? So human-machine interaction cases, particularly things like autonomous driving systems or driver assist. You don't really want the computer to crash out on you while it's trying to tell you where you need to turn on the road or whether you're crossing lanes. Particularly, you don't want the pilot of your aircraft to suddenly have everything go black when they're trying to land you at whichever airport is convenient to you. And equally on the compute acceleration side of things, if you have a compute accelerated system driving your car or at least providing you assistance in driving, then you really don't want that to fall over either. Basically anywhere that you want things to be reliable, this is a good case. Where you probably don't want to use it is for writing the latest popular game, because you don't want to certify for everybody's individual computer setup on the planet. You want to be able to take on the latest techniques that can be forced in more rapidly and deploy more rapidly. So I appreciate this isn't normally the audience for a safety critical thing, but there is enough in common between Vulkan and Vulkan Safety Critical that I'm hoping that if everybody here realizes that as part of their learning how to develop exciting new games, they could also make a load of money by going and working for a company that does safety critical stuff, then that's good news. So how do you get from Vulkan to Vulkan Safety Critical? Well, you start by writing in Vulkan. You may have to make some constraints to your program to do this, but make sure that all the compilations happen offline. Vulkan did start out with the premise that you could compile everything up front and not have hitches happening when your game engine is running, for example. So hopefully that's still a thing that's not a completely impossible concept. Obviously it doesn't work for every application, but for the ones that you want to be safety critical, it should be. And then the memory allocations that you were doing dynamically, now you need to know how much memory you were going to take up, so just track all of the resources that you are going to need, make those allocations when you set up. And that's all it is. And so the number of lines of code that you need to change to get things working is very limited compared to the total amount in a typical application. So where can you get Vulkan Safety Critical from? NVIDIA you've probably heard of, so I hope I don't need to explain them. Links, not just a text web browser, used to be Core AVI, also support a load of platforms for Safety Critical. It sounds like we only have 2 platforms here. Core AVI support embedded systems for Intel, AMD, a load of others. But if you actually want to start writing stuff, NVIDIA, you can run Vulkan Safety Critical on your desktop NVIDIA cards. So it's a little bit difficult to start writing code on an actual embedded safety critical device that doesn't have a keyboard and display attached to it and so on. So this is a really good opportunity to be able to write actual Vulkan safety critical code in a system that's familiar to you and experiment with it. And since NVIDIA are some of our competitors, I should say there is another way of doing it as well. There is a Vulkan safety critical emulation layer that will run on top of your normal Vulkan driver from anybody. We provide that through Kronos, and there are some demos that will run on top of it, and so hopefully you can use that to get things up to speed. There are a load of tools which I won't walk you through here. They'll be in the slide deck, but basically it's now becoming a mature ecosystem and hopefully convenient for people to use to start their development. So finally, here are links to everywhere. It sounds like we may be doing questions at the end, so I will not, in fact, ask for questions now. And I will return you to your normal Vulkan programming. Thank you very much.
All right, so I'm Henrik. I'm a software architect in the graphics platform group at Autodesk. My co-presenter is Michael. And Michael is actually going to do the main talk here about the recent Vulkan support in VRED and Alias. But before we go into that, I just want to mention a couple of other Vulkan-related projects that we have at Autodesk that might be interesting to the Vulkan community. Just showing this first. The projects and products that we're presenting here, they are all released, but we are making some statements about future plans, so just be aware that those plans could potentially change. So last year at the BOF, we presented a talk on adding Vulkan to Pixar's Hydra Storm renderer, and 2 years ago we talked about Vulkan support in Aurora. So both of those presentations are on the Vulkan YouTube channel, so if you're interested in more details, please check out the previous presentations there. But just quickly on these two. So the Storm renderer is an open source high performance rasterizer. It was open sourced by Pixar as part of their OpenUSD project. It is what is called a Hydra render delegate, which means you can use it with a Hydra rendering framework in any application that supports that. It supports all the major platforms, including mobile and browser, and we put a lot of work into Vulkan for both Linux, Windows, and Android. So you can check out the links. I mean, it's all open source, obviously from Pixar's repo, but we also have some contributions and additions on the Autodesk side that might be interesting to folks. And then Aurora, this is a complementary renderer to Storm, so this is a GPU path tracer for fast in-viewport rendering. It also supports the major APIs and of course using Vulkan for Linux and Windows there. It's also a Hydra render delegate. So again, all the source code is there on GitHub, and yeah, please check it out. And if you have any contributions, so always welcome, of course. So that was just a quick highlight on some of the other projects. But check out the presentations from the last 2 years' BOFs if you're interested in either one of those. And with that, I'll hand over to Michael to talk about the big news in VRED.
Yeah, hello. I'm Michael. I'm a senior principal engineer at Autodesk, and I'm working on the Autodesk VRED renderer. For those who don't know, VRED is a visualization and virtual prototyping tool which is focused on the automotive industry, and it's widely adopted among all the major car manufacturers. It's specifically optimized for handling engineering data sets, and it has support for virtual reality, mixed reality stuff, for collaboration across the world basically. It has Powerwall, cave support, and it also supports a large variety of industry standards like MaterialX, MDL, AXF, OpenColor.io, OpenVDB, and so on. The other software I just will quickly mention is Alias, which is our concept design and surface modeling tool, which is also mainly used in the automotive industry to create Class A surfacing and analysis. So I'm going to talk about rendering VRED, and we are basically having two different approaches. The first approach is we have a CPU and a GPU ray tracing engine, which is used for design reviews, but also for high-end marketing image production, for example, by Porsche or so. It supports clustering and multi-GPUs and has all the path tracing, photon tracing, spectral rendering, and all the features you might know from other renderers. What's more relevant for this talk is our OpenGL-based renderer, which is also used for design reviews, mostly in VR, because our ray tracers are fast, but they are usually not that fast to be able to use them in virtual reality. So with OpenGL, we have the classic feature set, I would say, like shadow maps, light maps, and for VR specific features, we have also multi-GPU support and variable weight shading support and stuff like that. Now, one thing though is the OpenGL rendering is really starting to show in its age. The quality is good, but it requires quite a lot of pre-computations, which can be very cost intensive. It takes a long time and a lot of effort for the customer to actually get it good results. And another thing that's limiting with OpenGL is that the CPU dependencies are really limiting performance, especially if you have hundreds of thousands of geometries you need to render. And also modern features like ray tracing and so on is completely missing. Another thing that's more specific to how it's integrated in VRED is we have a very tight integration with the OpenGL rendering, so it's basically embedded in the SIGGRAPH system we are using, and this is something we want to get rid of. And updates are pretty much brute force, which of course is also not the best to do. Another motivation we had is that Alias, which has the same problem basically of having a rather old OpenGL-based rendering, wanted to change their rendering as well. So our idea was that we can actually share the rendering technology between these two applications and base it on Vulkan. So our goals that we had when starting the Vulkan implementation was we wanted to be able to handle lots of geometries. So a single bumper for a car, for example, can consist of 100,000 surfaces, and we need to be able to still handle this efficiently. Another thing we decided quite early on is that we wanted to keep forward rendering and not go to a deferred shading model. Main reason for this is because we wanted, or we have to support arbitrary BRDF models and shader models. So all the AXF measured materials, for example, have to work, substance has to work, and they all have very different BRDF models, and deferred shading model is very difficult to have this working in. And of course, we wanted to support new rendering features like screen space refractions, this faster displacement mapping, and ray tracing effects. So when it came to the implementation, the first step we did is we implemented a new render API. The reason is we wanted to have the same interface for Alias and VRED they can use and not rely on any thread-specific stuff in there. The API itself has also a Hydra wrapper, so it can potentially be used from other applications as well, but at the moment both applications use it directly. And the API is optimized to really only trigger changes that are really necessary. On the Vulkan implementation side itself, then we decided to use a GPU-driven approach, so we can really limit the number of draw calls we have to make and have basically everything rendered by just using indirect draws. And this was very useful to render these high number of polygon scenes. The draw calls are batched per material state, and all the rest is happening on the GPU. So visibility evaluation, frustum culling, and we also have some quite efficient occlusion culling on the GPU to give us even more performance. Then on the feature set, we added quite a lot of ray tracing features, even for considering this is just our first release of the Vulkan renderer. So we have a hybrid rendering approach which mixes the ray tracing with the rasterized results. And basically there are two things we do. The one is ray traced shadows for ambient occlusion or for environment shadows, and ray traced reflections, which are single bounce ray traced reflections at the moment, which only sample the top level BSDF, and are then everything is denoised using either NRD or the DLSS RR denoiser. And let's look at some results. So on the left is our old OpenGL rendering with screen space ambient occlusion, and on the right is the new Vulkan renderer with all the features like ray traced reflections and ray traced environment shadows. And you might see it eventually that OpenGL is slightly stuttering, even though it's much worse when it comes to quality. And the frame numbers are sadly not very visible, but it's about 34 FPS in OpenGL and about 60 FPS in Vulkan. So even though we have these much more expensive features active, it's still a lot faster. And here's another quick comparison. On the left is the Vulkan renderer, and on the right is our full GI path tracing result. And it's rather close, it's not perfect. You are missing some of the indirect lighting, which is one of the things we are going to work on in the future. But the results are already very, very close, and our customers are very happy with it. So what's next? Multi-GPU support is one of the big topics that we are working on, because for the VR and mixed reality use cases, we really need it because of the large resolutions of the displays and the large geometries. And from our experience with OpenGL, we can say that we expect a scaling of at least factor 1.8 or something around that. The other thing is that we still use OpenGL for all the post-processing effects like glow, glare, and color management and so on. And this is also something that we want to move to Vulkan in the future. It's mostly done, but some work is still left. Other challenge we still have to face is that we need to be better at handling out of memory situations, which can be a little bit tricky in Vulkan. And on the performance side, we also want to investigate how we can use more parallelizations and also make better use of the different rendering queues. And that's basically it.
Right, thank you, Michael. So we're running a little bit late, but I think we have about 5 minutes for questions. If anyone wants to step up to the mic if you have any to ask.
Yeah, I was going to ask if there was any plans to implement finer grained synchronization in Vulkan, like being able to specify a dependency between 2 specific operations instead of putting some kind of sync in a linear timeline so that all the operations before you have to depend.
So I have seen a proposal for it, but the short answer is we don't have anything concrete to say right now.
Okay.
Hello. I'm curious how the performance of Cosmic Crisp compares to Molten VK right now.
Too early to tell. We're focused first on getting to 1.3 conformance and functionality, and then we'll start looking at performance tuning. However, that said, at the demo that you'll see at the table, we went through a bunch of the samples and various content, and the performance feels really good. So, but I'm sure that there'll be opportunities for tuning, but first let's get it working.
I have one more question about the Cosmic Crisp. Would you be able to share a little bit more about the implementation details? Is it based on Metal 3 or Metal 4? When was the project started? And is there any kind of timeline that we're currently expecting, I guess?
So it is not based on Metal 4. And I've seen social media comments implying it should be all Metal 4. It won't be. Aitor, who will be at the LunarG table, can explain to you why. Timeline is fall. We're looking, fall time frame, I'm not going to tell you which month because we're not exactly sure, is when we'll do the public merge request into Mesa for the driver. And we won't do it. We've had internal discussions about when's the right time to do the pull request, and we've decided we want 1.3 conformance. Now, everybody knows, well, maybe everybody doesn't know, but although you achieve conformance, it's still possible that there are workloads that are not working, or that there are bugs. And we used to say we wanted to wait until we had a lot more workloads running and we're really highly confident, and decided, no, we're waiting too long. As soon as we hit 1.3 conformance, we'll do the public merge request, and then this will enable many people out there in the community with their workloads to actually give it a test drive and let us know where the issues are. But
Thank you so much.
it's working pretty well so far.
All right, thank you.
Hello. You previously talked about hardware video decoding, and I wondered if you guys have any plans to also expose hardware image decoding. Formats like AVIF, WebP, or HAVE, they're based on video codecs, so it should be possible to leverage that hardware. But I think it should be also possible to expose that functionality through a simpler API that has less complexity, it's easier to use, that doesn't really require you to create a video stream in order to just decode one image frame, or that doesn't have as many restrictions.
There are no plans at the moment, but if you want to talk to me afterwards and explain the use case, I'd be interested. But yeah, currently no plans.
Thanks.
Okay, well, all of the speakers will be around for the networking session after, and I think Neil has a few words to say. If I can get us on to the next.
Your PDF is installing.
Oh, great. I can't even see well enough to...
Remove? Yeah. Yeah. Remove. Sorry, Adobe. So congratulations, you have survived another Kronos BOF day. Woohoo! Want to give a big shout out to the panelists here, to all of the speakers that have been speaking all throughout the day, and the last couple of days actually, and to you all for spending some of your SIGGRAPH time with us. We really appreciate you coming. And good news is that you are in the right place for free beer. So we're about to transition into the social networking event. We want to give a quick shout out to our sponsors, Cesium. I don't know if Patrick is here, but Cesium have been a long-term supporter, really driving GLTF, LunarG. Thank you, Karen, for the sponsorship. NVIDIA, well, they can afford it, right? So that's no big deal. But we love having you here. This is one of the main social events of the Kronos calendar. So no, thank you for being here, and we hope you stay and enjoy the evening. And this is actually a special BOF because Kronos was founded 25 years ago, and so this is our 25th BOF. The first one was back in 2000, and you can see some of the standards that we've managed to create over the years. Standardization is a community endeavor. It's cooperative. It relies on everyone getting involved. So we really wanted to give a special shout out to everyone who's been involved over the years, both Kronos members and members of the community. Thank you all for really making a difference in the industry. And we're just getting going. And from a personal point of view, I'm a little scared to admit that I was actually there in 2000. I've been in Kronos for 25 years. 24 years of that, I've actually been the president. And one of the best things about working in this domain is meeting all the like-minded people and making good friends. So it's been an honor and a privilege to work with you all. So if anyone here was here in 2000, I will personally buy you a second beer. So with that, let's have a good time. See you out there. Thanks, everybody.